Well, greetings everybody, this is Mark Anderson for Kellogg Community College, and in this video we're going to do a little introduction to infinite geometric series. Now, what you might think is that, hey, if I've got a geometric series and I'm going to infinity, will the answer always be infinity? I mean, seriously, if I've got 1, 2, 4, 8, 16, 32, and I add all of those numbers up and this pattern goes to infinity, I'll always get infinity. Or if I have negative 2, negative 4, negative 8, negative 16, that will go to negative infinity. Yeah, but there are certain cases where the absolute value of r, when the absolute value of r is less than 1, which is another way of saying if r is between negative 1 and not equal to 0, what you actually have is a situation where as you go to infinity, the actual number moves less and less and less because it gets smaller and smaller and smaller. I mean, take into account like this pattern right here. This is a pattern where a sub 1 is equal to 1/2. And if you then go 1/4 divided by 1/2 to find the ratio, 1/4 divided by 1/2 is the same thing as 1/2. So multiplying 1/2 by 1/2 gives you a 1/4, and then by 1/2 gives you 1/8, and by 1/2 gives you a 16th. As we go closer to infinity, that distance between the fraction and the next fraction after it will actually approach 0 and get negligible. So what we have is a new equation for the sum of an infinite geometric series as long as the ratio is between negative 1 and not 0. So it would be great to compare this versus the other video which talked about the sum of finite geometric series, because this formula, I mean, it's going to look really familiar. It's going to start with a sub 1, the denominator is going to be 1 minus r, and now you're probably wondering what else, but that's it. That is the entire formula. You might be used to the other formula on the previous video, which was, to find the sum of n terms of this finite sequence. You would take a sub 1 and 1 minus r raised to the nth power divided by 1 minus r. Well, this whole thing in the corner here, this in that rectangle that I just made, will approach 0 the higher you get to infinity here. So therefore, that r sub n, since it approaches 0, 1 minus 0 is just 1, and that's where we get our a sub 1. So since our 1 minus r to the n becomes 1 minus 0 as n approaches infinity, you get a. So we can use this equation to our benefit to go the sum of this infinitely big geometric series is going to be 1/2 minus, or over 1 minus 0.5, or 1/2. And this gives me 1/2 divided by 1/2, so the answer is 1. So 1/2 plus a 1/4 plus an 1/8 plus a 16th, as we get closer and closer to infinity, gets us to an answer of 1. Let me do 3 more of these here. I'll do 2 in this screen. So this is going to start off as 4. That's where it's starting, and it looks like it's going to be a ratio of, let's see, to figure that out, negative 2 over 4, which is going to be negative 1/2. So this is asking, okay, if you move forward 4 feet, then back 2 feet, forward 1 foot, back a 1/2 foot, forward a 1/4 foot, back an 1/8 foot, where are you going to be after an infinite number of steps? Well, this is going to be the sum starting off with 4 divided by 1 minus negative 1/2. And this is going to make then, if you do this out properly on the calculator and then convert it back into a fraction, it works out to 8/3, which is the same thing as 2 2/3. So if you started out by moving forward 2 feet, back 2 feet, forward 1 foot, back a 1/2 foot, back and forth, you will end about 2.6 repeating, or 2 2/3 feet away from the start. Now, down here, we're going to start off by moving a foot, and then we will move another 1/4 foot, then a 16th foot, then a 64th of a foot, because my a sub 1 is 1, and if I go 1/4 divided by 1, my ratio is 1/4. So my sum is going to be the starting place, which is a foot away from my starting position, and then I'll go 1 minus, and I can use a decimal or fraction here. I can use 0.25 or 1/4. And if I compute this out and turn this into a fraction, it's 4/3 or 1 1/3. which means that if I start off by taking a foot away from the center and then going a fourth, a 16th, a 64, I'll eventually end up, after an infinite number of iterations, about 1 1/3 foot away from where I began. So you can see that it will take an infinite amount of time to get from 1 1/4 to 1 1/3. So not a lot of movement there in that problem. So our final problem is going to be another oscillation problem, where someone's going to be asked to move a foot forward, then a half foot back, and then a quarter forward, then an eighth foot back. So my ratio is going to be, not my ratio, my a sub 1 is going to be 1, and my ratio is going to be -1/2 divided by 1, so -1/2. So my summation equation is going to be 1 over 1 minus, in this case, -0.5. And that will give me an answer if I do the problem out and simplify it into a fraction, 2/3. So if I move forward a foot, back a half foot, forward a quarter foot, back an eighth foot, I would end up around 2/3 of a foot away from my starting point, if I take, roughly an infinite number of steps. Well, thank you for doing this worksheet with me. We're going to do some applications next in sequences and series, and I thank you very much for watching.